Welcome to another video of Engineering Economics 2373. In this couple of videos this week, we're going to talk about the applications of the previous formulas that we have seen. Particularly in this video, we're going to talk about amortization tables. In the next video, we're going to talk about bonds. A typical amortization table looks like the one you have right now on your screen. In this example, we have a loan for $100,000. The interest rate is 5% and the number of periods is 5. We can see that at the beginning of the first year, the beginning balance is 100,000, and then the interest, since it's 5%, we're gonna consider $5,000 of interest at the end of the year. 5% of 100,000 is $5,000. Then we can compute the payment for each one of these years to be $23,097, and you can see that every single year for all the 5 years is $23,097. That is computed as the annuity, given that we have a present value of 100,000, interest rate of 5% and 5 periods, and the difference between 23,000 and 5,000, 23,097 and 5,000, is $18,097. That's how much, since we are part of the money that we're paying, 23,000, is 5,000 of those go to pay just interest. The remaining $18,097 go to reduce the amount that we owe. That's a payment to the principal. And then we have therefore a new balance of $81,902. That is generated as a difference between 100,000 and the $18,097 that were destined to reduce the amount we owe. At the beginning of the second year, we begin with $81,902. and 5% of that amount is now $4,095. We still make the same payment, $23,097, and therefore the amount that we have to reduce the amount we owe is $19,002 this time. If we subtract $19,002 from $81,902, that leaves us with a debt of $62,900. And that's the balance at the end of period 2, which is the balance at the beginning of period 3. Again, 62,900 generate a 5% interest, translates into $3,145. We still pay the same annuity, $23,097, and therefore we can destine $19,952 to reduce the amount we owe. So if we subtract that amount, $19,952, from the beginning balance, $62,900, then we have the ending balance of $42,947. If we keep doing that process in the next, for the following 2 years, we will end up with a balance of 0 at the end of the 5th year, therefore paying the amount that we owe fully plus the interest that we had. Now, as you can see, these tables can be computed row by row, and a computer would be able to do this for us really fast. But we can also find any one of these particular rows without having to resort to the computer. And even if, say for instance, you're applying these amortization tables to the payment of a mortgage. Let's say a mortgage for 15 years would imply 180 months, and you can actually compute any particular month. Say you wanted to know the 100th month results. You can do that without having to compute the previous, 99 rows above. So let's see how we can do that. The formulas that you have here at the right hand side apply for these loans and these amortization tables, and we're going to see how we can use those. The first one that we have is the unpaid balance, and the unpaid balance at T times T equals the annuity times P given A, I, and n minus t. Let's see what that means. So let's consider a loan. In a loan, you receive your money first, and then you make the commitment to make the payments later on. And let's say that you have paid, in this example that I have here, you have, let's see, we have 1, 2, 3, 4, 5, 6, 7 payments. And let's say that that was the original loan. The original loan was for 7 payments, but then you want to know how much you owe at the end after you have paid 3 payments. Well, you have already made 3 payments, so all these has already been paid in terms of these 4 payments. And making the resemblance of that, now we have equivalent of 4 annuities, the annuity at 4, 5, 6, and 7, and what we need to know is how much we would owe at period 3. So this is period 3, the 4th, the 5th, the 6th, and the 7th payment, and we can compute how much we would owe here. This would be the unpaid balance at t equals 3, and that is the annuity times P given A times the interest rate, and the number of annuities we have left is n minus t, and that's how we compute that. So if we go back to this table, we can compute the unpaid balance at any particular time. Let's say that we're interested in computing the unpaid balance at t equals 3. That means we want to know how much we still owe at the end of the 3rd period after we have made exactly 3 payments. That amount, of course, is 42,947. And based on the equation that we just saw, we can compute that number as the annuity, which is 23,097, times P given A for 5%, and then the number of periods is n minus 3, n minus t, which is in this example 5 minus 3 equals 2. And when we compute that, we get the right answer. The payoff, it's a quantity that is not depicted in the table, but it's the amount that you would need to pay in order for you to get rid of all your debt on that particular date. And that includes the unpaid balance at the end of the period and the annuity that would need to come with it at the end of such period in order for you to get all your debt paid off. So it is just the unpaid balance plus the annuity, and then you can, doing some algebra, you can end up with the equations that you see here. For the most part, the remaining of the operations are exactly what we've done before. The interest that we need to pay is the unpaid balance at the previous period, and we can do that in the table as well. So here the unpaid balance of 42,947 generate an interest of 2,147. And the amount that we need to pay, or that we reduce the principal by, is the annuity minus the corresponding interest rate. In this case, I'm using E of sub t as the notation for the amount that it goes to reduce the principal, and that is exactly what we've done in the table, which for the 3rd period would be 23,000 minus 3,145, 19,952. However, we might have computed the interest for the next period, so that would be that the payment of principal at t equals 4. If we have computed the payment at the unpaid balance at t equals 3, we can compute the reduction of principal at t equals 4 to be 20,950, which comes from the annuity 23,097 minus the interest on t equals 4, 2,147.